Hi, we are from Group 5. We'll be presenting the Experiment 5, which is Measurement of Jet Forces. We have 4 members, which are Nuratika Shaira, Nurul Hazmira Hani, Nurul Nadra, and Nurul Natasha. The objective of this experiment is to compare the force exerted by a fluid jet impinging upon a flat plate or a hemispherical surface with the theoretical values. These are the theory in this experiment. A jet of fluid when impinging upon a flat plate or a hemispherical surface, it generates a force due to change of momentum of the fluid according to the Newton's second law of motion. For example, when a velocity of water from jet nozzle with diameter strike on a flat plate or a hemispherical surface, the rate of change of momentum was produced, and its magnitude is the same with the force exerted on the surface of the flat plate or the hemispherical to support the water jet, as you can see in the figure 1. The force generated by the jet of water when it strikes depends on the shape of the surface. In figure 1 and figure 2, depict a jet of fluid issue from a nozzle of diameter moving vertically upward with the velocity which is v1 and strike a flat plate and hemispherical surface respectively. The jet is deflected by the surface of flat plate or hemispherical through an angle and leave the surface with the velocity which is v2. There are two figures. Figure 1 shown a jet of fluid strike a flat plate, while the figure 2 is the jet of fluid strike on a hemispherical surface. These are the equations of the theoretical force generated when the jet of fluid strikes on a flat plate and the hemispherical surface. F stands for the theoretical force exerted on the flat plate or the hemispherical surface. A stands for cross-sectional area of the nozzle. Rho stands for the density of water. Theta is the angle of water flow after impact on the flat plate or hemispherical surface. V1 is the velocity of water jet before impact on the flat plate or hemispherical surface, while V2 is the velocity of water jet after impact on the flat plate or the hemispherical surface.
Now, I will explain about the methodology for experiment 5. First step, the test deflector, which is flat plate, was assembled. Next, by adjusting the screw at lever mechanism, set the pointer to 0, which is 0 notch. On the lever mechanism, did not place any weight. The third step, the main switch and the pump were turned on. Next, the flow control valve slowly opened and desired weight, such as 1 Newton, was put on the lever mechanism. The flow control valve was adjusted until the pointer at the lever mechanism is at 0 notch. The fifth step, the sliding valve was closed. By recording the time required to fill up 3 liter volume of water in volumetric measuring tank, the flow rate of water, which is capital Q, was determined. Next, the sliding valve was opened. Step 4 and step 5 were repeated by increasing the desired weight on the lever mechanism until the flow control valve is at maximum opening. Next step, the main switch and the pump were turned off. The sliding valve was opened and the flow control valve was closed. Next, the weight on the lever mechanism was removed and the deflector was changed from flat plate to hemispherical surface. The last step is steps to to step 7 were repeated. That's all from me. Thank you.
Okay, for the results, we have presented it in these two tables. For table 1 is the data for flat plate, and for table 2 is the data for hemispherical surface. From the raw data given, there are measured force, which we denoted as FMEA in Newton unit, volume of water collected, and time in second. So same for the data for hemispherical surface, but in order to complete the tabulation of data, we have to calculate the Q, flow rate, velocity, theoretical force, and also the percentage of reductive error by using the formulas that I will explain later. So basically, these are the data, the complete data that we have calculated from the experiment conducted. Okay, so these are the formulae used in calculations. In order to get the value of Q, which is the flow rate, we use the uh, formula Q equals to V over T, which V is the volume of water in meter cube unit and T is the time in second. And then for the value of area of nozzle can be obtained from the formula A equals to pi r square, which is the area of circle. Since in the value of diameter of nozzle is given, then we can find the radius of the nozzle uh, by dividing the diameter into 2. Okay, so we after we get the radius, and then we can insert in the formula to get the area of the nozzle. And be noted that the diameter is converted from millimeter to meter to standardize all the units. And then with those two being calculated, the value of velocity can be obtained by using the calculated area and Q with the formula velocity equals to Q over A, which Q is the flow rate of water in meter cube per second and area of nozzle in meter square. And then for the next one, to get the value of the theory, F theory, force theory, which denoted as FTH in Newton unit for flat plate, the formula used is F equals to rho AV square. In this unit, rho is the density of water in kg over meter cube. A is the area of nozzle that we have calculated earlier in meter square, and then V is the velocity in meter per second. Meanwhile, for the hemispherical surface, the formula used is that we just multiply it by 2, and the formula is the F equals to 2 rho AV squared, which are the same with the previous one. Rho is the density of water, A is the area of nozzle, and V is the velocity. And lastly, for the percentage error, the values were obtained from the formula absolute FMEA minus with force theory divided by force theory times with 100. So in this formula, FMEA equals to F measured that were given to us in the raw data in Newton unit, and FTH is the one that we calculated by using the formula also in Newton unit.
Okay, so Tasha will explain about discussion. So the first question in this experiment is we need to estimate slope of the graph for both plate and compare the theoretical value as shown in equation 2 and equation 4 respectively. So we need to comment on the difference. So basically the answer for theoretical slope of the graph for plate surface is 0.9998 and hemispherical surface is 0.9998. And for measured, the plate surface is 0.9844 while the hemispherical surface is 0.9996.
to estimate the y-intercept ratio of hemispherical surface to flat plate and compare the theoretical ratio as deduced from equation 2 and equation 4. And we need to comment on the difference. So the answer for y-intercept ratio for measured value is 0.798, while for theoretical value is 0.728. Question is, we need to compare the force exerted on hemispherical surface with the one on the flat surface. So which one is greater and why? So from the data, we can conclude that force exerted on hemispherical surface is greater than flat surface. This is because the change in momentum on hemispherical surface is bigger than the change in momentum on the flat surface. So when water jet from nozzle hit hemispherical surface, high energy produced, which enable the water to reserve its direction. High velocity impact causing total energy exerted and time taken shorter. So while for the flat surface, water only flow in one direction, lower is push and the time taken also become longer. We need to compare the percentage of relative error for both flat plate and hemispherical surface as a function of jet velocity. So we need to comment on the analysis and explain your reason. So for flat surface, the average that we got is 8.998, while for hemispherical surface is 15.468. So we can conclude that flat surface have lower percentage than hemispherical surface. So one of the reasons is the plate may not perfectly shape because the angle is different from original. So ensure shape of coil must be straight, positioned to make sure the velocity of water that strike on it more pressure and accurate. Next, we need to briefly discuss on factor contributing to error or inaccuracy in experiment data and possible recommendation to improve existing result. So factor contribute error is parallax error due to position of eyes during reading measurement. So how to improve? Eyes must be perpendicular to the calibration scale. Next is control valve not fully open before adding the weight, which might affect the reading. So we need to make sure control valve is fully open. And the last one is bubble exists in the pump. So way to improve is we need to make sure bubble is removed by opening valve before conducting the experiment. So application, we need to give two application of jet impact in industry. The first one is water jet cutter. So by using the high pressure and high velocity of water jet together with abrasive substance, water jet cutter is capable to slice metal or other material. The process of water jet cutting is similar with water erosion found naturally but occur with highly accelerated and concentrated. So the second one is generate electricity. So impact of jet is used to rotate the turbine, namely Pelton wheel in the generator. The water jet is applying force tangential to the wheel. The tangential forces of water jet generate moment or torque on the wheel to its maximum value and therefore increase the mechanical energy of Pelton wheel. The rotational energy of wheel is then converted into electrical. So the conclusion that we get from this experiment is force exerted from flat plate is lower than the force exerted from the hemispherical plate. Due some error occurred during the experiment data deviated from the theoretical value. So we can conclude that theoretical for plate surface is 0.9998, which is same with hemispherical surface, while the measure is 0.9844 and hemispherical surface is 0.9996. That's all from me. Thank you.